All right, hey, what's up, guys? Mr. Forden here with a second video. It's late in the 8th block. Whew, it's late, 4:30 p.m. And thank you for arriving to yet another math class today. You Geo folks, this is your third math class today. Anyways, the last video I just shared with you was 795B, which you need to do for homework tonight. I went through the method that I talked about most during second block today, which was how you can use the equal values method to determine what A and B are. And then you got yourself a y equals a times b to the x little function equation. So good to go. Okay, so just recap on that one. Isolate a on both equations. Okay, once you get it isolated, you can set the two things that have b in it. You can set them equal to each other because they both equal a. Solve for b. Okay, and then once you have b, you can plug it back in to one of the original equations you had. Solve for a. Boom, you've done the system. Then you just plug a and b into y equals a times b to the x. Voila, you have the answer to the problem. Faster way to do it, though, guys. Faster way to do this is much good. Thank you for somebody, I'm not going to say their name, but for pushing me on this, because we didn't have as much time in third block here, but pushing me on the elimination method. I tried to talk about the elimination method. Second block didn't really go so well. So that's why I'm filming this video again. Second video here is, okay, third block, here's how I taught you. Here's a video, in case you're having trouble with it, to follow the third block method, the elimination method. I'll take you through it, okay? Keys to the elimination method is we're going to eliminate by dividing. Okay, that's a little hint here. Eliminate by dividing equations. Okay, equations. So if you remember, we used elimination in today's lesson. We used elimination for the linear systems that we had here. We subtracted to eliminate. What do we eliminate? We eliminated b. Y equals mx plus b. It's always y equals mx plus b, so you can eliminate that b very easily. We subtracted equations. For an exponential, you're going to have to divide equations together. It's called the division property of equality. That's why you're allowed to do it. Okay, so let's just get set up again here. I was set up in class, and hopefully we get this nice and easily here. Y equals, oh, no, I'm not doing y equals mx plus b, because guys, it's an exponential function. Okay, so we're going to have here y equals a times b to the x power. Then what am I working with? Other given information I have is 1.75. My y coordinate, x coordinate is 2. xy is negative 228. Okay, so I can set up a system with x being 2, y being 1.75 in one equation, x being negative 2, and y being 28 in another equation here. Okay, so let's take a look at my system, and then let's do that. Let's do that elimination method to solve this nice and easily. It'll be a lot cleaner than the last video that I just put together. Okay, so what we have here is x is 2. Let me set up my system here. Okay, I'll move this 2 into a y. So a, b, we don't know. Right? We don't know A and B yet because there's no way to tell what my y-intercept is, right? No clue what my y-intercept is. I got 2, I have negative 2 for x. I don't know when x is 0, I don't know what y is, okay? So I have to determine A here. B, well, there's kind of some ways you can figure out B right now. It's going to involve taking 4 through, potentially. Ooh, let's see where 4 away next. Anyways, don't worry about that now. Don't worry about B because we have the rest of this to fill out here, and we can solve A and B by a system of equations. Remember, a system of equations is at least 2 equations that share the same variables. So here, A and B are going to be the shared variables here, but we know this coordinate point is going to have to work in our equation eventually. So x is 2 and y is 1.75. Okay, we'll put them there. Okay, another point we know will work in the equation that we'll eventually get, right? So we're kind of starting using stuff that works in the equation before we actually have the equation yet. Okay, is going to be when x is negative 2. Okay, remember x is the exponent in an exponential functions equation, and 28 is your y. Okay, up here. We got it set up. Okay, elimination method. Remember, for your linear functions, what did you do? You subtracted both sides from the top here. You do that for the subtraction property of equality. Subtract one thing from one side. As long as you subtract an equal amount from the other side, the equation remains balanced. Well, it turns out, right, in geometry we'll talk a lot about this, you can actually divide. Okay, you can divide sides. Okay, divide sides here. As long as you divide the left side into the left side here and divide the right side into the right side here, that's a valid move. Why? If I take a side and I divide it by 28, as long as I divide my other side by 28, my equation is going to remain balanced. The is equal to statement is going to remain valid. Well, am I dividing by 28 to both sides? Well, yeah, I'm dividing by 28 for sure here. But guys, guess what? That's 28 as well. 28 equals. It's equal to a times b to the negative 2 power. This is just some random mumbo-jumbo algebra. What does it represent? It represents 28. Okay, so what I'm going to do here is I'm just going to divide this. So you might be asking yourself, why is this elimination? Okay, it's because we're eliminating A. Okay, eliminating A. We're dividing both sides here. So if I have this here, A divided by A, what does it equal? It equals 1. It equals 1. That's why we're able to cross it out, right? And then 1 times B squared is just B squared, okay? So we're dividing here. Okay, this is messy here. 1.75 over 28. I'm going to take that, and I'm going to use my trusty calculator. I did this in the last video, so I might be lying that I'm doing it to you right now. 1.75 divided by 28. Okay, I got 0.0625. Okay, after I do my division, okay, I get here 0.0625. That's 1.75 divided by 28. Okay, and what is it equivalent to in terms of this situation? Well, I'm dividing this side by also 28, but disguised, it's a times b to the negative 2 power. Okay, the a's canceled. Here I have b divided, b squared, I might break it apart, b squared divided by b to the negative 2 power. What's the rule? What do you do with the exponents here? What do you do with the exponents? When we're dividing things with a common base, what do we have to do with the exponents? Well, hey, remember, x to the m over x to the n equals x to the m minus n. So you're doing b to the second power minus negative 2. Be careful about that. It's not b to the it's not going to simplify to b to the 0th power, because subtracting a negative is the same thing as adding. So what I'm going to get here, I told you to do this earlier, that number 4 has something to do with it. B to the 4th power is what b squared divided by b to the negative 2 power simplifies to. Okay? What are we going to do now? How are we going to solve for b? Well, you guessed it. I told you this earlier. We were going to have to take a cube root. Okay, fourth root. My bad about that, fourth root. Because a fourth root is the opposite of taking something to the 4th power. It cancels it out, right? It undoes this thing to the 4th power, and that's what I want. So I do this on my calculator. You might be thinking, well, 0.0625, taking the 4th root. Ooh, what is that possibly going to be? Well, it turns out it's 0.5. Here, I'll do it on my calculator. I'll do this button here, iPhone, with the Y root X button. And I specify my y, that's the root here, is 4, fourth root of that. Okay, it equals 0.5. Well, that's interesting. What's another way I can write 0.5? 1/2. Okay, 1/2. And if you think about it, right, how does this 0.0625 connect to a half? Well, a half is 0.5. So if I multiply 0.5 4 times in a row, my number goes down, right? So my number is right here because 0.5 times 0.5 is 0.25. And then times by 0.5 again is 0.125. And times by 0.5 again is 0.0625. So you see my number went down and down and down again. And that's why they have this problem for you. It looks a little scary to the decimals, but it's not too bad. I have B here, okay? Elimination method. Well, just look at, I wrote so much less third block than I wrote the second one. How's about that, okay? All right, so there's my B. What do I got to do? I got to go back and get pluggy back in to get A. Okay, so let's use maybe the one that doesn't have this. So I'll use this equation here. 28 equals, okay, and B is a half. Okay, well that's the negative 2 power. Okay, and I have A here. So now I can get A. Right now I have to deduce what my multiplier has to be. So I got 3 out of my 4 unknowns here. Where did I get this stuff from? Well, I got it from that I knew I had an x value, I had a y value that worked in my equation. I just need to figure out what that equation is. So I plug in y here, I plug in x here. Now I'm going to go ahead and get A. Remember, negative exponent, what does it do to a fraction? It flips it. I went over this in the other video. X to the negative 1 power is the same thing as 1 over x. Okay, same thing as 1 over x. So if I have x to the negative 2 power, that would be the same thing as 1 over x squared. Over here, right? Well, I already have it, so I'm going to flip this. Okay, 28 equals A times by 2 to the pot. So that's what a negative exponent does. Flips a fraction, you make it positive, right? That's the trick here, okay? 2 squared, well, that's obviously 4. I'm going to bring that to the front of this, A. I got 4A equals 28, so what does A have? Well, divide both sides by 4. 28 divided by 4 is 7. Okay, 7. 7 equals A. Got my parameters, baby! A and B are all about the parameters here in this action, so I'm just going to plug in 7 for A, plug in 1/2 for B, and I got myself an answer. Y equals 7 times by 1/2 to the x power. Success. Good times. Thank you for joining me for 8th block Algebra 1. And it took me a solid 40 minutes to make this thing done. Thanks, guys, for watching. Take care. See you guys tomorrow. Bye.